I have at least one group that's definitely on the right track.
Yeah.
Could you get the distance from here to here?
Yes, I did.
Yeah, or
Oh wait, difference in the secant.
is that good or bad?
That's bad.
Bad. What's better?
One underneath
Like take two? Better?
Oh, and then do three.
And then infinitely many. Okay?
Where on it?
So now infinite triangle hypotenuse. Okay? What is this side? No. No.
And x minus h.
No. No.
An x.
What?
A dx.
This isn't dx. This might be dx. This is delta x. This is delta y. Okay, so infinitely many, infinitely small would be dx and dy. So how would you find each distance?
Square root of delta x squared plus b squared.
Okay, now that still has a long way to go.
Limit.
No limit, that's what the integral does. A to B is good. So, all right, so if I said, all right, integrate that, what would you do? Kind of, it's a bit of a mess, yeah? Why is it a mess? Okay, two differentials. So make it so it's one differential. PZ squared.
Oh, wait, that's still
dy.
right? Is that would be DZ squared?
No, stop.
dy is the first. Stop.
F prime D.
D.
Oh, you just keep the
Yeah, dy.
Now algebra.
So, oh, you just want us to foil.
There's algebra to be done.
Oh, see, I don't
square root of 1 plus f minus.
There is a greatest common factor of
Yeah.
dx squared, which if you factor out, then square root, it is.
Yes.
That is how you find arc. Right. Pythagorean theorem and infinitely many pieces, and then using differentials to replace the dy. Okay. Now that said, you can, besides finding length with x as the variable, which is what we just said, 1 plus the derivative in terms of x squared dx, you could also use y, in which case, if I use, say, I had a function of y, g, y, then the arc length would be from a y range, the low of the curve to the high of the curve y value style, of 1 plus the derivative g. So it's 1 plus the derivative squared, square rooted, from lower to higher. Okay? So say you had the parabola curve, which was from 0 to 0 to 3, 9, and you wanted the length of that curve. You could actually find the length of that curve using x or y. If you use x, then it's an integral of mini Pythagorean theorems. From where to where? 0 to 3 of the square root of what plus what squared? 2x quantity squared dx. Now, most of these, unfortunately, if I were making this textbook, you would have learned trig substitution and secant cubed integrals, and then this, because you cannot integrate this by
Yeah, I can't wait.
Oh, it's awesome. Secant cubed will take you a sleep. Okay? This you can use a calculator. Throw it in your calculator, please.
Okay.
It's not a use sub candidate. It can't be integrated by hand unless you know trig substitution, which we will learn next week. Next week.
This is
Yeah,
our,
really close to the point.
Yeah.
that's
I might buy like-
7, 4.
Mr. Rickman, is that your stats book?
No, it's Ms. Weber's, but
You've
and
gotta teach both periods.
no, just first.
You've gotta teach both. Wait, you teach stats now?
I'm going to Ms.
She's
Weber's.
pregnant.
Okay,
Giving birth.
what'd you get?
Giving birth.
9.747? Yeah? Okay. Now try doing the same curve, which obviously should be the same length, but using y as the variable.
Okay.
Oops. And this goes to where your calculator is ignorant. It'll just mindlessly plow ahead and give you a numerical answer. Although this is an improper integral, which we haven't learned yet either, but we will.
Oh, because you could take this
What's wrong with this integral?
I guess it's the
There's a, oh,
It's actually not defined. It's an asymptote there. So, and yet the calculator says, whatever, I'm just going to make some calculations and throw a number at you. And what does it say? Does it say the same number?
Wait, yeah, so.
And it should.
Wait, Mr. Richmond.
Yes.
So in order for calculator, I just take
The Inspire's program to go within, I think, 1,000. And then some intervals, maybe 100,000. The 84 was 1,000. Yeah, it's just, it knows no calculus. It's actually calculating the singularity. Yeah, it's crazy. All right.
You know mine.
Would you try the back one on your own, which is no calculator? Then we'll be good. I'm trying to give you a little more practice with y, because our book almost always just gives x, not y practice, and you need to be able to do both. Many of these you'll need a calculator, but this is not one of them. You should be able to integrate this. Would you actually use said that or mentally use said that? Okay, whatever works for you. At this point, I guess we'll call it good because I don't know 325 to the 3 halves. Guess that's where I would start. You with me? Okay. All right then. What about ye old 106 worksheet? How did that 106 worksheet go?
Is that the fun sheet?
The fun sheet. Yeah, sorry, fun sheet. It wasn't a worksheet. I didn't give you a worksheet. I gave you a fun sheet. I forgot. Sorry.
So fun.
No.
All right. Shall we talk about 7-5?
It's just math. Some of us.
7, 5, 8, 9. Let's go on the front side. 7 was the first issue. Yes.
I'm good there.
Okay. Does anybody need 7? No. Okay.
Sure.
Yes, 7. Okay. They say time is greater than or equal to 0. The x dt is 2 minus sine t squared. Time equals 3. The position is 2, 7. X at time equals 6. Okay, this one should be more up your alley. To find position at time 6, you need its position at time something. So, for example, I know position at time 3, and I know how the position is changing. So I could take the initial condition plus the change in condition, or change in position, to get ending position at time 6. So that's just forget the y in this condition plus change. Okay, anything else on page front of 1? How about page back of 1?
For 9A.
9A, yes.
So I get it, like looking at it, the key, but when you plug in the 0.101 to get the C,
Yes.
when it's 1 equals root 9 plus C, why isn't it plus or minus root 9? Like, because that could change what C is.
Yeah, I agree. That's a good question. So I understand what you're saying. You've then, you're kind of confusing yourself, really. If I asked you when you were a 4th grader or 6th grader, what's the square root of 9? What would you say? 3. Now, so to answer your question, I know there's a fine line between these two questions. This means what times itself equals 9. This means what times itself equals 9. And surely this is plus or minus 3, but this is not plus or minus 3. It's just 3. Now that's the reason is when you do a square root, you use what's called the principal root, which is to say the positive. When you do a plain old square root, it's just.
Okay.
All right. What else on that second page?
5.
5? Okay, 5. 5, I think I did this uglier than I needed to. I was tempted to eliminate the parameter first, but I think it was ugly. So, wouldn't you agree that the horizontal tangent is if dy dx, the slope, remember, now I understand the confusion. There's 3 different derivatives floating out there. There's dx dt, dy dt, and dy dx. you're still looking at for where the slope is 0. So you're looking for where the derivative is 0, yeah? Now in terms of the components, does that mean you want to find where dy dt is 0, dx dt is 0? You want the top to be 0 because that's horizontal. The bottom 0 would be vertical, right? Do you agree? You get a vertical tangent if the denominator is 0. So I want to know where dy dt is 0. So find dy dt, which is, I suppose, quotient rule, low, b high, minus high, b low, over the square of what's below, square. Did this go anywhere?
Wait, can you cancel out the 1 plus, or can you just get rid of the 1 plus t cubed squared?
I don't really care because that would be undefined and that's not going to select the I. So you can just focus on the top. 4t to the 4th minus 6t to the 4th plus 1. That feels okay. Yeah, negative 2t to the 4th plus 1. Make sure I get this by the end of the day, much to your chagrin. I get 4th root of 1/2. That's not right. What did I do wrong? Oh, this has a 14. Sorry, this isn't 1. This is 14. Yeah. Sorry. No. I feel like 14 to the 4th minus 16 to the 4th plus 14. So negative 2t to the 4th plus 4t equals 0. Negative 2t squared t cubed minus 2 t equals 0, or the cube root of 2. Okay.
So it's D, right?
D, yes. Correct.
This is due today.
It is due today. He's been there for at least since yesterday. We'll finish going. You can go over more later, but anyhow, I do this. So much to do.